All right, welcome to this session of the Fusion 360 Hackathon, and this is an introduction to the Fusion API. And my name is Brian Ekins. I'm the designer of the Fusion 360 API, and we'll be presenting the next few technical sessions about the API. So let's go ahead and get started. So first, I want to present kind of high-level conceptual view of how the API works. So internally, there's this Fusion engine, you can think of it. And the engine, what it knows how to do is to read and write this Fusion data. And this data is stored away on disk or in A360 as an F3D file. But the engine knows how to work with that data. And as part of the engine, there are a series of what we call requests. And so, for example, there's a request for creating an extrude. And so that extrude request knows how to create the data that represents an extrusion. Okay. So now when a user wants to create an extrusion, so we have a user interface for that. So the user interface provides a view of the data. It's able to create graphics based on that data and display those to the user so he can interact with the data through the user interface. And now when I want to create more data, and for example, an extrude, then I run the extrude command, and that brings up a dialog, and then the dialog guides the user through the required input to create an extrusion. And so he picks the profile, says what kind of operation he wants, what the extents of the extrude are. So he defines all of that required information. And so nothing's really happened in Fusion yet. He may be getting a preview, but nothing permanent has happened yet. Then when he clicks OK, the command calls the extrude request and says, okay, create the extrude with this data. And so that request knows how to create the data, and now we see the graphics are built and the user sees the result of what he's done. All right. So the API is similar to the user interface in that I need to gather the input. So instead of having a nice dialogue to guide me, the API is kind of attempts to do the same thing but through code. And so in my code, I'm gathering the input that are needed and defining the different settings. And then once I've done that, then I call a function which passes out all that data to the request, and that same request, just as it did from the command, creates the data for the extrusion. And so it's doing the same thing. It's calling the exact same function inside Fusion to build the data. It's just how does it collect that? And so we'll be talking about this programming interface and how that works. So before we get into details, just to clear up maybe some misconceptions, is if you go to the File menu, the very bottom command on that is this add-ins legacy command. And there was a previous Python API that was started and has since been abandoned. But there are a couple of add-ins that still use this. That's why it's still in the user interface. But that's going to go away when those add-ins get moved to the new API. So just ignore that. It's not something you want to spend time with because it's going away. All right. So the new API was started as a project about 2 years ago, and the idea for this new API, the architecture for it, was that there would be a single API design, but exposed through multiple languages. And I'll talk more about that with some examples as we get later into this presentation. So this new API was first released just a little over a year ago, and the first release supported JavaScript, and then the next release we added support for Python, and then just this past July, support for C++ was added. So a little bit of the concept of this new API, how it's structured, is it's around this, call it this object model. and it's this hierarchical chart, and every little box in there is represents a class, or sometimes call them objects, and most of those have a one-to-one correspondence to things in Fusion. So there's a little box in here that says sketch line, and that object represents a line in a sketch inside Fusion. And there's an extrude feature, and that represents an extrude feature. So there's a one-to-one correspondence between a lot of them. And then there are quite a few objects that are API specific only. They help to provide the structure in this, and some utilities that are useful when working with an API. And we'll look at some examples of that in a few minutes. So this hierarchy, it's not a class structure like you would be familiar with in a lot of other charts like this, but it's defining ownership. And so you see the same kind of thing in the user interface too, but you usually don't think about it. But you think about, if I have a sketch line, so what owns that sketch line? What does it live inside? It lives inside a sketch, right? So what does that sketch live inside? Well, it's owned by a component. And then, so what owns that component? Well, it depends on if it's the top level component in a design or a subcomponent. But because it might be owned by another component, or it might be owned by the document. And so you have this ownership, and that's what's shown in this hierarchy. And so to get to specific objects, I have to traverse this hierarchy to get to the specific feature or sketch line or whatever that I want to access and work with. And we'll see this in action in just a minute. All right, so when we began this API project, the initial target audience was for end users that were writing script, mainly to automate tedious tasks. And so what do I mean by that? So let's say you're doing a design and you need a gear, right? And I want it to be an accurate gear, so I want some true involute teeth. And so to do that, I can pull out my calculator, maybe Excel. I look up the formula for creating an involute and calculate some points along that tooth. I input those into Fusion, fit a curve through those points. Now I have half of a gear tooth. I can mirror that over, pattern it around, and now I have a gear. So it was quite a bit of work, not very fun, but I finally got my gear. But now I need another gear that's a little bigger, so it has more teeth. And so now I start that process over. And so it's just not very fun. But now I can write a program, and I define all those calculations once as code. And now I just change the inputs, and it generates a new gear of different size. And change the inputs again, generates a different gear. So I automate all the tedious task. And here's another example, something I was playing with recently, where this is just a solid. It happened to be a revolution to start it off with, and then I had some smaller little partial toruses, and position those little toruses around the model and subtract them out. So then they look like little gouges on the model. And so I could do this manually by taking the component that's that partial torus and using the move feature command and positioning it all over the model, and then using a feature to subtract that out. But to write a program, then it just helps automate all that process. So it's a lot easier and more fun to use. Another common thing is to import and export data. So for example, I might have an Excel file that has XYZ coordinates that I want to fit a curve through. So I could read those and automatically fit a curve through it. Or I want to export some parameter values into a file. So a key thing for this kind of target audience is for the API to be able to do the same things that you would do through the user interface. So having equivalency with the UI. And here's a chart that kind of demonstrates where we are with that right now. I won't go into a lot of details, but so this is the model workspace, and everything that's in green, you should be able to do the same things that you can do through the UI, you can do through the API. What's in yellow, you can do some of what you can do through the UI, so there's limited functionality, and what's in red, the API doesn't have any support for yet. All right, here's the same chart for the patch workspace. And in addition, the API also supports this preferences dialog that has all these settings, so you can get and set all these settings through the API. There's some basic data panel support. So through the API, I can find out what projects this user has, and then in a project, find out what folders there are, what are the files, and then with those files, I can open it inside Fusion. I can create a new file in Fusion and save it to a specific directory. I can upload files to A360. There's support for local translators, so that means just locally on my local Fusion, I can save out, say, as STL or step, and I can also read in from a local file. There's the ability to access the timeline, so I can do reorder and suppress and create groups, that kind of thing. There is no support for the other workspaces. So I showed modeling and patch, but there is no support for render, animation, sim, cam, or the drawing. Some other functionality that's in the API only, and it's only API because it's not really needed in the user interface. And the first of these is to be able to query the model shape, and this is through what we call BREP, or boundary representation. That's a term for just how solids and surfaces are represented inside Fusion, and to get their geometry. And the reason this is important in the API but not in the UI is, let's say, for example, you create a box and you want to fill it 2 corners. So if I do that in the user interface, I draw a box, and then I know which 2 edges I want to fill it, so I just pick those and add the fillet. But now if I do that through a program, I can draw the box, but now how do I tell it those 2 edges without asking the user? I know which 2 edges I want, but so I need to use this part of the API to be able to query, so I can ask the box, okay, what are the edges that exist in this box now? And then I could look at those edges to see where they're positioned in space and figure out which of the 2 edges I want to add the fillet to. The assembly structure is available through the API, so that's basically the equivalent of what you see in the browser. Through the API, you can create your own custom commands. So they have these dialogues so that they look to the user just like a Fusion command, because it's the same kind of dialogue, the same inputs, and they guide the user through collecting the needed input for that command. And then I can customize the UI, which mainly means I want to add the button that executes that command somewhere into the UI so the user can run that. So I can create a new command and then position a button wherever it makes logical sense in the user interface. And I can access the camera, so I can change the view and manipulate that. All right, so I said initially when we started this project, the target audience was end users wanting to automate processes, and that has changed. And so now the target is more professional developers and advanced users, and really what that means is anybody that will write add-ins and share those with other people, either freely or for a price. And the idea is that there's more and more people adding value to Fusion by creating this new functionality. And one way to distribute that is through the Autodesk App Store, previously called Autodesk Exchange. And of course, you can still, and this hackathon is really meant to start populating that app store to get people to be looking more at Fusion, to see if to look at the API and see if there's functionality that they need to create apps that they think might be useful to our customers. Right. And then you can also, you're not limited to selling these on the App Store. You can also sell them yourselves directly. Some other functionality that we added that's more targeted towards this new audience versus just the end users is add-ins. And really what an add-in does is it lets you install something on that machine, and now that add-in's there, that add-in can support commands. Fusion finds them automatically on startup, and then the add-in can add buttons into the user interface. And so by having the add-in there, to the user, it just looks like there's new standard functionality inside Fusion. So he runs Fusion the next time after that add-in was installed, and now all of a sudden he has new capabilities. And every time he uses Fusion after that, those new commands are available. And another key thing for this new audience was to be able to support C++, because they don't want to work in these scripting languages, but want to create true binaries and use a language that a lot of professionals tend to use and are more familiar with. So. All right, there's some functionality that we still want to do in the future, and I kind of want to call out some of the big ones here because it might impact ideas you have for writing an application now. But first one of these is attributes, and so this is the ability to attach any information you want to Fusion entities. And for example, I might have an app that creates bolts, and so the user specifies what kind of bolt he wants, and then it draws the bolt, and now I have that in my design as a component. And so I want to add attributes to that component to say this is the kind of bolt it is. So now the next time when the user says he wants a bolt and he happens to specify the same bolt, I can reuse that one instead of creating a new one from scratch. But attributes are very useful to be able to just add information and also just be able to kind of name entities so I can find them later. Custom graphics. So this is when you have data, maybe a table or some simulation results or any kind of additional data that Fusion doesn't really know about, but you want to display inside the Fusion window. Then you could use custom graphics to do that, and there's not support for that today. T-splines, there's no support in the API to create or edit T-spline data. You can query the results of T-splines because when you leave the T-spline environment, that T-spline data is converted into a standard solid model, and then I can use that existing BREP API that we talked about a minute ago to query it, but I can't create or modify T-splines. There's no events associated with modeling. So for example, if I want to listen to see if the user changes a parameter or if the model just changes in some way, and then I want to react to that and update some stuff that I have, I can't do that because there are no events associated with any modeling changes. And custom UI, so I showed a second ago that custom dialogue, and that you can create your own commands with those dialogues. And today you're limited to that, to creating those kind of dialogues with the kind of controls that the API currently supports. But if you need a more advanced dialogue that maybe has tables and graphics and all kinds of stuff, then currently there really isn't a good way to do that. And there's lots more that we need to do, and we need your help in understanding, what you need. And we have a good idea of what's still missing in the API, but we would like some advice from you so we know really what's the most important to the most developers so we can prioritize. All right, so choosing a language. And so we first added support for JavaScript, and JavaScript was designed to work in a web browser and to react to and drive an HTML page, right? But that's not how it's used in Fusion. And in fact, you can't use it with HTML. So you can't create your own form using HTML and use that. So it's just a general purpose language. And a limitation of JavaScript that's intentional, because you don't want to load up a web page and have it reading all the files on your disk, is there's no file system access. Right? So to work around that, because that is an important part for a lot of programs, is the Fusion API for the JavaScript implementation for it. It adds additional functions that let you access the file system. So you can use that if you are using JavaScript. And with JavaScript, you can use any text editor you want to write code, but we deliver one editor with Fusion called Brackets that we'll use by default. And I'll show that in a minute. And then debugging is done in Chrome if you're using Windows, or in Safari if you're on Mac. And JavaScript runs out of the Fusion process in its own invisible browser instance. And you can use additional JavaScript libraries, so you're not limited to just what's built into JavaScript, but you can use other libraries if you want. And then if there are errors when you make API calls, it throws asserts, and so you can catch those with the try catch statements. And one limitation with JavaScript compared to the other languages is not all events will be supported. And this is just a limitation for the time being, but you need to be aware of that. All right, so Python. So I said JavaScript runs out of process. Python runs in process within its own Python interpreter. And mainly because of that it's running in process, it's much faster than JavaScript. And to give you an idea of faster, so I wrote a little program that calls into Fusion and just gets a value that Fusion already has. So Fusion doesn't have to do any work, but there's just an API call to ask Fusion for a value, and then Fusion passes that back. And so that program, which basically just tests what's the overhead of making an API call, is 275 times faster in Python than in JavaScript. And so then I wrote another program that draws 100 lines. And so now with each call, Fusion's having to do some work on its side. And so in this case, Python is 23 times faster than JavaScript. And so if I write another program that's forcing Fusion to have to even work harder, then that time difference is going to be less. But I think it's safe to say that Python's always going to be faster than JavaScript. With Python just built into the language, you have full access to the file system. And our experience so far with working with developers is they've just run into a lot less limitations when using Python. And some of them started out with JavaScript and then switched to Python because of some issues. With Python, you can again use any editor you want, but we deliver an editor called Spider, and you'll probably want to use that for editing, even if you're used to another editor, because we also use Spider for debugging, and it tends to be more convenient just to stay in the same thing for editing and debugging. And you can use, even though Python itself is pretty rich, what comes with it, you can use other Python libraries too. And just like JavaScript, it also uses asserts for errors, so you can use try catch around those. All right, C++. So this is a little different. You have a DLL on Windows or a dylib on Mac, and that loads and runs in process to Fusion like Python does. So it's going to be the fastest. It's just Python isn't known for its speed. But C++ running in process, it's going to be the fastest of any of them. I haven't done any tests for how much faster, but I'll need to do that. It'd be interesting to see. And just build into C++, you have full access to the file system. When you create a new script or add-in, we create a Visual Studio project and an Xcode project. And then when you open up this, and when you edit the script or add-in, it will open up Visual Studio or on Windows and Xcode on Mac. And you can use any code editor you want, any compiler you want, as long as it'll create a standard Windows or Mac binary. But that we default to these two. And because C++ is strongly typed, you tend to get better code hints when you're typing your code. And C++ doesn't fire asserts with errors. Instead, it uses the more standard C++ method of returning errors, and where each function returns an error code. And with C++, you have to compile for each platform. So I need to compile and create the DLL for Windows, and then I have to take my code and on a Mac compile it and create the dylib. So you have to have a Windows and Mac and compile it on each one for each machine. All right, now I want to look a little more at just some basic concepts of this API, looking back at this object model that we looked at briefly before. And so every box in here represents an object, and every object can support methods, properties, and events. And there's a few objects in here that we call collection objects. So they're the same as the other objects. They can support methods, properties. They could support events, although collection objects don't tend to. And the collection objects, they're all the boxes in the chart that have rounded corners. And they provide access to all the existing objects of a specific type. And it's also through collection objects that you create new objects. And so, for example, here's the sketch arcs collection. And so every collection supports a property called count and a method called item. And count tells me how many objects are in that collection, and item lets me get those objects. And so I could, if I ask, so the sketch arcs, I could call the count property and say it returns 3. So then I know there are 3 sketch arcs in the sketch that owns that sketch arcs collection. And I can get those by calling the item. So I call item sub 0, item sub 2, items, or item 1, item 2, and that would return the 3 sketch arcs in that collection. And then to create a new sketch arc, there are add methods on this collection, and I can call those, and that will create new sketch arcs within that collection, or adds new arcs to this sketch, basically. And so this hierarchy, so I go from the application down to the document. The document owns the design. Design owns components. Component owns sketches, and sketches own curves, and those curves are arcs, circles, ellipses. It also owns dimensions, points. So again, this hierarchy defines this ownership. There are also some objects that aren't shown in this chart, but we'll see in a minute. We call input objects, and they gather up the input for creating more complex kind of objects. And they're kind of equivalent to the command dialogues in that, again, they have the properties and things that define what's needed to create an object of a certain type. And so you fill in those properties and then pass that into the function that actually creates the object. Okay, so here's some examples that illustrate how you would use this object model, and also show how how it's used in these different languages. So illustrate the idea of having one API that's exposed through multiple languages. And so on this first line, we call a static function on this, and then that returns something. And what that's doing is that's getting this top level application object and returning it. So with that call, now we're hooked into this object model. And so we have a reference to the application object. And it has a property called active product. So we're calling the active product property on the application object. And that's kind of shortcutting us down a little bit, is so the application knows what the user is currently editing, what's open in the UI that the user is working on. And this code assumes it's a Fusion design is what he's working on right now. And so this shortcuts us down to this object. So that's what we have in this variable called design, is we have a reference to a design object. And then in a design, the very top level node in the browser, there's always one top level node that's referred to as the root component. So that's the top level component that owns everything else in that design. And so the design has a property called root component, and that returns a component object. And then on that component, we call a sketches property, and that returns a sketches object. So now we're at this object. It also has a XY construction plane property that returns the construction plane that represents the XY plane. So now we have a variable that's referencing that. And then on the sketches collection, it calls an add method and passes in that XY plane, and then that creates a new sketch. And so now we have one of these objects that we've just created using this sketches collection. And then on the sketch, it calls a sketch curves property, which returns a sketch curves object. And then the sketch curves object has a property called sketch circles, which returns a sketch circles object. So now we have this object. So we're just stepping down this ownership tree. So now we have a sketch circles object in this circles variable. And I call the add by center radius method on the circles collection. And we pass in a point, and this is a point 3D. So this is just it's basically just an API wrapper over an XYZ coordinate. And we're calling a static function on this point 3D class and saying we want to create a point at 0, 0, 0. So that's the center point of this circle, and the radius is going to be 2. So this creates a new circle on this sketch and passes back the circle. And then also a sketch owns sketch dimensions. And so it's calling sketch dimensions property, getting this object, the sketch dimensions object back. And then on that object, it's calling this method, add diameter dimension. And it's passing in the circle and also defining another point for where the position of the text of the dimension is going to be. Right, so that's this program to draw a circle and add a dimension constraint to it in JavaScript. And here's the same code in Python, or code that does the same thing in Python. And you can see it's doing exactly the same thing. The syntax is a little different, how I define a comment. There's no semicolons at the end. I don't have var where I'm declaring variables. So if I go back to JavaScript, Python, but you can see that the bottom line, it doesn't change at all other than the semicolon at the end of the line. And mostly it's just the var being added and the way the comment is done. And C++. So now that we see some more changes, so there's bigger differences in the syntax. So here I am having to declare every variable as a certain type, and it uses this PTR template. And so here we're declaring a variable using that as a design object. But that's what we're doing here. We just didn't have to declare it. So we're declaring design and we're setting it to the active product, and that's what this is doing. So again, just a little bit different syntax, but it's still doing the same thing. Okay, so again, one API, and it just exposed through different languages. All right, here's a little more complex program. So the first part's doing the same thing. It's getting the root component, creating a sketch, adding a circle, but then now we want to create an extrusion from that circle. And so from the sketch, it calls this profiles property, which returns a profiles collection, which you can see here off of a sketch. And it's getting the first profile in that collection. And what a profile is, if you've drawn in Fusion in a sketch, when you're drawing in a sketch, when you draw a closed area, it kind of fills in with a different color. And as I draw multiple geometry in that sketch, it'll continue to fill in. And if there's overlapping areas, there'll be multiple areas filled in. So now when I go to create the extrusion, it asks me to pick the area that I want to extrude. And I can pick one or more of those filled in areas. And those are called profiles. And in this case, I created the sketch from scratch, and I created one circle. And so I know it just has this single profile defined by that one circle. And so I just get the first profile from the sketch. And if I had a more complex profile and I needed to, or a more complex sketch and I needed to find a certain profile in that sketch, you could do that too. You could examine all the profiles and find the one that you need. But in this case, I can just get the one and only profile that's there. So now I have a reference to this profile. And so from the root component, I get the features collection. And from it, I get the extrude features collection. So now we have this object. And I call a property or a method on the extrude features object called create input. And I pass in the profile. And the second argument is what kind of operation do I want this to be? So do I want to create a new component or a new body, or do I want to add material to an existing body? So what kind of operation? And so this creates an input. So this is kind of like the dialog for the extrude popping up and having the profile part of the dialog and the operation part of the dialog already filled in. And now I need to specify the other options. And the reason those are kind of already filled in is I always have to provide those. So it's just asking me to provide those up front, since that's always required for every extrude. And then the other settings on the dialog can be different depending on some other settings that I pick. So do I want to create an extrude that's a certain distance, or do I just want to go up to a certain face? And in this case, we're on that input object. We call this set distance extent method to say we want it to just go a certain distance. This first argument says if we want to go in one direction or in two directions, and we just want to go in one direction. And then this defines a distance. I won't go into detail on this right now. We'll talk about it later in another session, but that I want to go 5 centimeters in the positive direction. So now we've defined that. So now the input is fully defined. And on this extrude features collection object, which we have this reference to, we call the add method, and then just pass it the extrude input object that we've fully defined now. And so then that calls the extrude request inside the Fusion engine, and the extrude is built. All right, so let's kind of look at this in practice. And so I'll go to Fusion. And the heart of the API, of the user interface for the API inside Fusion, is this scripts and add-ins command. And this consists of 2 tabs, one for scripts and one for add-ins. And then in each tab, there are two folders. So in here I have my scripts. So these are scripts that I've written or installed on my machine. And I have this sample script. So these are ones that are installed with Fusion. And so I can run, I can debug, and I can edit these existing scripts. And I can also create new scripts. So that's what I want to show here. And so on this create new script, I can pick if I want to create a script or an add-in, which language, and some other information with it. So I want to create a script. Let's start with JavaScript, and let's call it this so it'll show up at the top of my list. And create. I could fill in the other stuff, but I don't have to. So now we have a new script, and I'll edit that. And so this is brackets editor. And here's the code for this. So this first part is JavaScript specific. It's how debugging is done. So it'll hit this debugger statement if I'm debugging and break there. So then I can add additional breakpoints. And but mainly what this program is doing is it's getting the application object. From the application object, it's getting the user interface object, and then it's calling the message box. So it's basically a hello world starter program. So we can just run this. And there we go. Right. So let's make it a little more interesting, and so you don't have to watch me type. I'm going to go back and grab this code. And we'll copy and replace this with it. Whoop, not Python. We want JavaScript. There we go. Okay, and I'll just save that and go back to Fusion. Here's the program, and I could just run it, but we want to debug. So there's a drop down here. I can run or debug. So debug. Now Chrome starts up. My program is running and it's hit that debugger statement. And so now I could add other breakpoints, continue running. Now it's hit that breakpoint. I can step through and I can examine variables here. This is where actually JavaScript is really nice, and Chrome here is great for debugging because I can hover over this and it shows me, oh, that's a design object. Here are all the properties that object supports. And so I could get, say, the root component. So that's a property. If I click that, it tells me that will return a component. I can double click on that, and then it will show me all the properties that that object has. And so anyway, so this is really a live view of that object model chart we were looking at. So I can traverse down through the object hierarchy and look at values here. And so let's continue stepping through this code. So now this next line is going to create the sketch, and there it just showed up in the browser and down on the timeline. And this line is going to create the circle, and there it is. And then it added a dimension. Now it's done. Right? And I don't see the dimension. That's because the sketch isn't active. And with the API is independent of the user interface context. So I don't have to activate a sketch to be able to edit it. But that dimension is there. So now if I do edit the sketch, there I can see the dimension was really created. All right. So let's just get out of that. We'll go back to add-ins, scripts and add-ins dialog, and we want to create another script. So a script, this time Python. Create that and edit. And here we go. So same thing as before. It's a little bit simpler code. And we'll go get the Python code from here. Just copy and paste that here. Save. Again, we can go to Fusion, pick that script, go here and debug, and you can see spiders flashing down here. So we've hit, it breaks at the top line. I can now add other breakpoints, let it run. Now it's hit that breakpoint. I can step through. I can examine variables. So if I just type in sketch, so it tells me, oh, that's a sketch object. I can say sketch.name. So it was named sketch1. So I can call properties and look at values here in the console window. So not quite as nice as you can still get the job done. So it's adding the circle and then the diameter dimension. Right. So there we go with Python. So now let's do the same thing with C++. Let's get a new file. All right, so again, we go to the scripts and add-ins dialog. I want to create this time a script and C++. And create. So there it is. Again, edit. So because we're on Windows, it's opening up the Visual Studio project. And here's my C++ script. And let's do the same thing as before. So I'll just grab this C++ code from here. And replace all of this stuff. And save, and now I need to compile. So it's not just a script that's interpreted at runtime, but I need to compile and build a binary. All right, and then to debug, I actually start the debugging from Visual Studio, as I need to attach Visual Studio to Fusion. So go to debug and use the attach to process. And I wanted to make sure this attach to is set to native code. And then I look for Fusion 360 and attach. Okay, and it may want to load some symbols, so let it go ahead and finish doing that. Let's say I want to add a breakpoint here. Now to actually start debugging, go back to Fusion, just like before. Scripts and add-ins, pick that CPP, and there is no debug in this case because I'm not initiating the debug from Fusion, but I started it really from Visual Studio by attaching Visual Studio to the Fusion process. And so now when I just run, it's going to run my program that's running inside Visual Studio. And so now I've hit that breakpoint here. I can step through my code and do the standard debugging inside Visual Studio. And so there we go. We just created our sketch using C++. All right, so to get some more information about the API, so the first place to look is the API documentation. And let me just demonstrate some of this. So if I go to Fusion and go to Help, right, there's this programming interface topic. And then that takes me really to the overall Fusion help, but it brings up this page, which over here in the table of contents, you can see programming interface. And this is really the welcome to the Fusion 360 API topic that's shown here. And what we're looking at is a newer format for the help and for that they've introduced for Fusion, but it's not very friendly when using the API help. And so you can still use the old format. It's the new content, but it's the old format. And you can get to that if you just use Google, and you can do Fusion 360 old format or old help format. And the first topic that comes up will be for this Mod the Machine blog, use the old Fusion 360 help format. And so this is a topic I wrote where it discusses this a little bit, but provides a link to the old help format, the layout for it. And so I would do that once, and that's also the URL. If you can see that, you can just type that in and go directly there, but then you can save that as a favorite so you can quickly get here. And in the help, so in the table of contents, here's the programming interface. And we've got the welcome to the API. There's a what's new topic that at the top will discuss kind of big areas that are new for this API, and any changes, things you need to be aware of. And then it'll have a detailed list of all the new objects and all new methods, properties, and events that have been added to existing objects. Then there's the user's manual. And so this has several topics that give overviews of different areas of the API. So how to create scripts and add-ins, and how to do commands. And there's these topics on things that are specific to Python, C++, or JavaScript. And so you'll definitely want to look through that for whatever your choice of language is. Right. Then this area, which is the biggest area, is this reference manual. And here are all of the objects inside Fusion, so listed alphabetically. And so I can pick that. So that this describes the extrude features collection. You can see it has the item and count and some other things. And so it shows me all the methods and properties. And if there are any samples, I can access those from here. And so I could go to this method, and then so it shows me the syntax for that method in Python, JavaScript, and C++, and what any values are, any parameters that are input, and describes those. So this is where the details of the API exist. And then there's also the same sample programs that you could link to from those topics are here in the categorized, so you can go to samples. And samples have, most of them are in JavaScript, Python, and C++, and they're just copy and paste into an existing script, and you can run them and see how they work. All right, so there's the API documentation. There's the samples. So the samples I just showed in the help, and the samples that are delivered with Fusion and scripts and add-ins dialog. You can use there's an API and scripts forum online, and so you can ask questions there. It's also a good place to go look to see if your question has already been asked and answered. And for this hackathon, you can use this email address if you have any questions. And here are some of the upcoming sessions for the Fusion Hackathon. And so that concludes this session. So thank you for listening in, and I wish you good luck on developing your app for Fusion.